Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, the topic here we are going to discuss it is oxidation state and rules to assign that. Now, the word here we have oxidation state, as we have a lot of atoms and the compounds of different elements in which the atoms may have the charge +1, they may have +2, or likewise they may have the -2, -1, and so on charges. Now, why do they have these type of charges, and what these charges we may call it, and how do we may be able to assign these charges? For example, if we have the metals, when they lose the electrons, they carry the charge in the positive way, and when we have non-metals, they can gain the electrons and they carry the charge in the negative way. Now, how do they gain and lose electrons and what they do have these type of charges? So we will learn about this. Basically, this is known as the oxidation state, which is oxidation we have the loss of electrons, or it may be increase in the oxidation state of an atom, ion, or a molecule in the chemical reaction. Oxidation state can be explained or can be defined as it is basically an apparent charge that an atom will have. It may be carried by an atom, have in a molecule or in a compound, or maybe it is present in a molecule or in an ion. That apparent charge is known as the oxidation state. Now, the oxidation state is just developed due to the loss of electrons, and it is an increase in the oxidation state. The simple example of the oxidation process here we have this is the rusting of iron. For example, here we have the iron when it come in contact with the oxygen and the water or in the presence of the moisture is the formation of the compound as FeOH whole thrice. This formation just happened and the rusting of iron just started. So this is the simple oxidation process. Now, when the iron is going to react with the oxygen and water molecule, its oxidation state changes, and this apparent charge that it may have, it is known as its oxidation state. Likewise, we have a sodium. By losing one electron, it carries a charge +1. Now, this +1 or positive one is its oxidation state. On the other hand, when we have a chlorine, by gaining one electron, it carries a charge -1. Now, this negative one, it is its oxidation state. Now, here we have the rules to assign the oxidation state. Basically, there are four rules from which the first one we have the oxidation state of uncombined elements. If we have an element that is in uncombined state or it is in the free state, how we can be able to identify its oxidation state? It will have the oxidation state that is 0. When an element is in the free state or in uncombined state, its oxidation state will be 0. Likewise, if we have the simple sodium, it has not lost or gained the electron, its oxidation state will be 0. If we have the zinc, its oxidation state is 0. If we have the helium, if we have the neon, all the noble gases, and all the elements that are present in free state. Likewise, if we have H2, its oxidation state is free. If we have Cl2 form, its oxidation state is free as it is in these are in uncombined state and these are combined state with their atoms. So that's why both atoms are same. Their oxidation state will be 0. There is no discrimination between these elements in a molecule or in any compound. So this is the oxidation state of uncombined state. You guys must remember the oxidation state will be 0. Next, the second rule we have, it is the oxidation state of ions. The oxidation state of ions will be same as the charge on ions. So if we have the ions of the group 1a, they can lose the electrons and they can carry the charge which is +1. So their oxidation state will be +1. If we talk about the group 2a elements, they can lose 2 electrons. So their oxidation state will be +2. Likewise, so on increasing. It means the ions that have charge on them, this is their oxidation state. Likewise, sodium has plus 1, magnesium have plus 2, aluminium has plus 3. On the other hand, when we talk about chlorine is having negative 1, we have oxygen, it is having minus 2. So these charges are their oxidation state. The ions that have their charge is their oxidation state. Then we have third rule, which is the oxidation state of a neutral molecule. Likewise, if we have a molecule like H2O, now what will be the oxidation state? The oxidation state of this molecule will be 0, as we will take their algebraic sum, and their algebraic sum will be equal to 0. For example, the hydrogen, its oxidation state is plus 1, and oxygen, its oxidation state is minus 2. Now, by assigning the oxidation state to the hydrogen, we gain oxygen minus 2. Here we have hydrogen, its oxidation state is plus 1, and here we have two atoms of hydrogen, so plus 2 and minus 2, their algebraic sum will be equal to 0. Likewise, if we talk about the HCl, here chlorine have minus 1 charge and hydrogen have plus 1 charge. Their algebraic sum is equal to 0. So the oxidation state of neutral molecule, its algebraic sum will always be equal to 0. Now here we have the fourth one, the last one rule, the oxidation state of the complex ions. Now the complex ions are the ions which are also called as the molecular ions. When a molecule gains or lose the electrons, then they carry the charge which is known as their oxidation state. Likewise, if we talk about the carbonate, CO3 minus 2. Now here it carries the charge minus 2, as this is a compound CO3. How to? Where oxygen is having charge minus 2. Here's 3 atoms are present, so multiply by 3, we will gain oxygen as minus 6. And carbon belongs to group 4A, its oxidation state is plus 4. Now, carbon plus 4 and oxygen minus 6. Its algebraic sum will be equal to minus 2, so the carbonate will be as CO3 minus 2. This is the carbonate. Likewise, if we talk about the bicarbonate, it is HCO3 minus 1. Now, this minus 1 we will calculate is hydrogen plus 1, carbon plus 4, and oxygen 3 as minus 2 multiplied by 3, we will gain minus 6. Now its algebraic sum of plus 1, plus 4, and minus 6, we gain minus 1. So the oxidation state of bicarbonate is negative 1. So this is a simple rule to assign the oxidation state to the complex ions or the molecular ions. Now here we have the oxidation state of some group elements. Likewise, if we have group 1A elements, their oxidation state will be plus 1. There is no exception in them. We have group 2, their oxidation state will be plus 2, and there is no exception in this. On the other hand, when we talk about the hydrogen, it contains plus 1 in all the containing compounds that have non-metals. But when it is making hydrides or the metal hydrides, we talk about the metal hydrides. So metals have capacity to lose electrons. So when it combines with the likewise magnesium hydride, here the hydrogen will have the minus 1 charge. Fluorine, it contains minus 1 charge, as all the halogens or the group 7A elements will have minus 1 charge. Here we have oxygen. It carries minus 2 charge all over, but when it is forming hydrogen peroxide, its charge will be minus 1. So this is the exception of the oxygen and the hydrogen. On the other hand, chlorine is minus 1 charge. Other values when bonded to the fluorine or the oxygens may be changes, but all over it contains the minus 1 charge. So this was all about today's lecture. I hope you guys understand, and if you have any queries, you may ask me about that in the comment section, and I will get back to you guys soon. The next topic that we will discuss, it is the determination of or determining the oxidation state of an element in a compound. For that time, you guys keep learning and have a good day.